Very good morning, students. For this lecturing video session, I am going to solve one more problem from the chapter projection of straight lines. Right? Let me just read out the question and make you understand what kind of projections need to be done and the extraction of given data. Right? A line AB is 75 mm long. What exactly it is? It is a true length AB, line AB, right? If it is given the front view length or top view length, then that is the front view length or top view length. Here it's mentioned a line AB 75 mm long, that is true length. Has one of its end 60 mm in front of VP and 20 mm above HP. And the other end is 20 mm in front of VP and HP. The top view length is 55 mm. Draw its front view. Right? Draw its front view. Right. So let me just extract the question here. Given data. Given data. A line AB is 75. That means true length. True length is 75 mm. As one of its end 60 mm in front of VP and 20 mm above HP. That means the first end is A, therefore the locus of A information is given. What it says? 60 mm in front. 60 mm in front of VP. In front of VP. And 20 mm above HP. And 20 mm above HP. And the other end is nothing but B. What do you mean by line? These are 2 points connecting the shortest distance of 2 points is the line. So, if you term this as A and this as B, the A distance, that is the locus A, I have captured here, and the other end is nothing but B. So, what it says? The other end is 20 mm in front of VP. So, B 20 mm in front. So, 20 mm in front of VP and above HP. And it is mentioned above HP, distance is not mentioned. But it is rest assured that the other point would be above HP. So, some distance above HP. Fine. And the top view length is 55 mm. Where you get the top view length? On the locus of A, that is top view length. Top view length, which is nothing but AB1. AB1, which is equal to 55 mm. 55 mm. So, before proceeding the projection, you check whether you have 5 inputs or not. Without 5 inputs, you cannot proceed the projections. Look at here 1, 2, 3, 4 and 5. So, to finish or to complete the successful projection, one must know 5 inputs. So, let me just draw the XY line, that is the reference line. Above reference line, it is VP and below is HP. First, we will have to start drawing the locus. So, locus information to be considered first. Let me just choose A, that is 60 mm in front of VP. In front means it will capture in the HP. So, 60 mm from the reference line. Take 60 mm from the reference line and draw a parallel line to the XY, that is reference line. Take 60 mm from the reference line and draw a line parallel to XY, that is reference line. And this can be named as locus of A. Right. Next, 20 mm above HP. 20 mm above HP. So, if it is above HP, when you just look at from the front, it will capture in the VP. So, take 20 mm above the reference line and draw a line parallel to XY. Draw a line parallel to xy, that is reference line, and this can be termed as locus of A dash. So both the data have been utilized here. Let me just move to the other end, the locus data, 20 mm in front of VP. So in front means it will capture on HP. So take 20 mm from the reference line and draw a parallel line to the XY, and this is nothing but locus of B. To get the projection of straight lines, we need to have the locus of B dash too. So 4 locus, that means loci, that is locus of A dash, locus of B dash. So if you know all the 4 locus, then only you get the final top view and the final front view. So I need to find the locus of B dash, isn't it? So for which I am going to take the top view length. Top view length will be captured on the locus of A, right, in the top view. So choose a point, just draw a line, any point, should be perpendicular to the XY. So let me just choose this as A, and locus of A dash, it should be A dash, this projector line, right, it should be perpendicular to the XY, should be perpendicular to the XY. Fine, and the distance is 55 mm. The top view length will obtain on locus of A, which is 55 mm. Take 55 mm by using the scale, mark that point 55, and this point as B1. This distance is top view length. This is top view length. This is 55. Understood? So this is top view length. What about its front view? For which we'll have to project the projector vertically upwards. Vertically upwards. Do you know the locus of B dash? We don't know, right? So let me just project this line which is being projected from the top view length, right? Now let me just take the true length, that is AB 75 mm compass. Take 75 mm compass and A dash as center, cut an arc which has been projected from the top view length, somewhere like this. And this is true length, therefore this point can be named as B1 dash. Now draw a line parallel to XY on the intersection. This is nothing but locus of B dash. This is nothing but locus of B dash. Now connect the point A dash and B1 dash. It's a thin line, right? Connect the points A dash and B1 dash by thin line, right? So now the projection of top view length being projected here, we got the true length, right? Now what I have to do? Next I have to draw the true length on the locus of A. Right, take 75 mm compass, take 75 mm compass, keeping A as center, take 75 and cut an arc on the locus of B, and this point could be B2. Now draw a line connecting the point A and B2, This is nothing but true length. This is top view. Then what about its front view? We'll have to project that line to locus of A dash, So B2 becomes B2 dash. Then what about this distance A dash to B2 dash? The distance between A dash and B2 dash is nothing but the front view length. The distance between A dash and B2 dash is nothing but front view length. Right. Now, we got the projection for the true length. This is the true length and its projection top view length. The true length on the top view and its projection, that is a front view length, has been obtained. Now, what is the method we are adopting here for projection of straight lines? That is a rotating line method, right, isn't it? So now, take the distance between A dash and B2 dash in your compass. A dash and B2 dash in your compass. And A dash as center, cut an arc towards B dash, that is locus of B dash. So the flow is like this. So it started from the true length and extended to locus of A dash and it has been rotated to locus of B dash. This intersection point is nothing but B dash. By connecting the points A dash and B dash, you will get the final front view. This is final front view. By connecting the point A dash and B dash, you will get the final front view. Right. Now, this is over. Now, what about the final top view? So, take the distance between A and B1. A and B1 in your compass and A as center. Rotate towards locus of B, where B is here. So now rotate it. So the flow is something like this. So it started from here and it has been rotated in this fashion. Now this intersection point is nothing but B, point B. Now draw a line connecting the points A and B. This is nothing but the final top view. This is nothing but final top view. Is it clear? What are the things should be drawn as dark as far as projections of straight line is concerned? The final front view and the final top view, these are the two things should be drawn as dark line. Rest everything should be as construction line by using 2H. Only the final front view and final top view should be drawn by using H or HP pencil. Right. We have obtained the projections, right, that is final front view and the final top view. What is next? We will have to capture all the dimensions in the drawing, right. So let me just draw the dimensions here. Let me just mention the dimensions here. So for locus of B, which is 20 mm, isn't it? So 20 mm. And for locus of A, which is 20 mm above HP, again 20 mm. And 60 mm in front. So from the reference line, take 60. This is the dimension, that is 60 mm. So top view length has been marked here as 55, isn't it? Now what is left? The true length. So true length can be captured in the front view, right, by drawing a perpendicular line to the true length. Perpendicular line. Similarly, here also perpendicular line. Right. Now draw a parallel line to the true length, and both the boundaries should be mentioned with filled arrows, and this is 75 mm. Check whether all the 5 dimensions have been captured here, true length has been captured here, and the locus detail have been captured, and the top view length has been captured. What is next? The nodes needs to be captured. So it should be mentioned in the right bottom of the diagram. Since I don't have sufficient space left out here, therefore let me just draw it here. So by opening the guideline of 5 mm, all dimensions are in mm. whatever dimensions consider here to complete the successful projection, I consider the unit of dimension as mm, isn't it? So, all dimensions are in mm. Then what about the scale? Since I have used the actual dimensions, whatever given, same thing I just used here. Therefore, it is a true scale. The actual scale has been considered, therefore, it is a true scale. Scale 1:1. So, check each and everything whether you have left out anything. So, the projection is obtained, dimension is marked, notes have been captured. So, with this I have completed the projection of the straight lines, right. And so, before you completing this, you need to take the inputs, that is within the box the 7 parameters needs to be captured, isn't it? What are they? It starts with AB, that is a true length, then theta, that is the true inclination, with HP, and pi, which is the true inclination with VP, and alpha, which is the apparent angle of HP, that is alpha, and beta, which is the apparent angle of VP, beta. Then what else? The final top view, which is AB, and final front view, which is A dash, B dash. This should be in mm, and this should be in degree. This also should be degree. This also should be in degree. This also should be in degree, and mm. The final view should be in mm. How this can be measured? By using the scale, the final front view and final top view can be measured. And what about the true inclinations and apparent angles? Using the protractor, you will have to take the given angle here, that means the angle of true inclination with HP, apparent angle of HP, the true inclination with VP, and the apparent angle of VP. So, that is the reason I always insist for you to check before you proceed to the next diagram, right. So, with this I have completed this drawing. Hope you have all understood it. Thank you.